Section 6.6 is on page 408, talks about moment and center of mass. We're going to just focus on center of mass. So, centroid, or center of mass. The center of mass of a lamina, that lamina right there, with density delta over the area under the curve of y equal f of x, if x is between a and b, denoted by x bar, y bar is given by x bar equal 1 over m, integral from a to b, x times the density times f of x, and y bar is 1 over m, 1/2 the density times f of x squared, where m, this m, is actually the integral from a to b of delta times f of x dx. So, this point right here, this is where you find the balance for this specific lamina, in which if you put a pin and you put it flat, it will balance out. So, I have a couple of problems to do. This is not a long section. These formulas are provided on your test. You don't need to look for them and memorize them. I will provide them on the test. On page 419, I'm looking at problem number 24. It says, find the center of mass of a thin plate covering the region bounded below by the parabola y equal f of x, the y equal x squared. So something like and the line y equal x. Well, the line y equal x, I'm going to blow that out of proportion of it. So 1, 1. That's how the parabola look like. And the line y equal x runs through 1, 1. So we're talking about this region right here. We want to find where to put the pin so that we can get the balance. Put a pin somewhere in it and lay it flat, and it should balance out. That's the idea. So first we need to find what m is. M is the integral from a to b. We're going to run this dx. It's going to be from 0 to 1 of delta. If the plate has a density of 12x, delta, which is 12x, times f of x, and f of x in this case would be what? The line minus the parabola dx. So, m would be 12 times x squared over 2. I messed up. Forgive me. That's 12x. There we go. So 12 times, and that would be x squared minus x cubed. So x cubed over 3 minus x to the 4th over 4 from 0 to 1. M would be 12 into 1/3 minus 1/4. All over 12, that's 4 minus 3. So m would be simply a 1 in this case. Wow, okay. X bar would be 1 over m. M is 1, the integral from 0 to 1 of delta times x. So delta is 12x times x times the area x minus x squared dx. And that would be 12 times the integral x squared times x is x cubed. X squared times x squared is x to the 4th. So I could simply integrate that and say that is x to the 4th over 4 minus x to the 5 over 5, evaluated from 0 to 1. That's 12 into 1/4 minus 1/5. and that is 12 times over 20. That's 5 minus 4, which is 1. So this would be divided by 4, that is 3 divided by 4, that's a 5. There it is. And if I go for y bar, okay, I'll tell you what, easier. Just redo the whole thing. And if I look for y bar, according to the formula up there, y bar is 1 over m, m is 1 in this case, the integral from 0 to 1, and that's going to be 1/2 delta is 12 times f of x squared. And here, what you're really doing, if you recall from first semester calculus, you take the top and you square it minus the bottom and you square it. X squared, let me write that down for your notes. So don't subtract, don't square that, that doesn't work. And that is 6 times the integral from 0 to 1 of x squared minus x to the 4th dx. Y bar is 6 times x cubed over 3 minus x to the 5 over 5 evaluated from 0 to 1. So that's simply 6 times over 15. I'm rushing, I don't know why. 1/3 minus 1/5. Y bar would be 6 times all over 15. That is 5 minus 3. So y bar would be divided by 3, that's a 2. Divided by 3, that's a 5. And that right there is a 2. So y bar is 4/5. So the centroid for this x bar, y bar is actually 3/5, 4/5. And isn't that 0. What is that? 6? 0.8. So if you move 0.6, this is 0.5, this is 1, 0.6, and that's 1, 0.8 is about right. Okay, my graph is off slightly. 1, 0.6. Something's not right. Let me just double check that really quick. Yeah, somehow it's oh, I see. I forgot again. This is actually 12x. You guys didn't say anything. So everything's the same except there's an x there. Which makes, if you multiply, which makes this x cubed minus x to the 5th. So this is x to the 4 over 4 minus x to the 6th over 6. So that would be 1/4 minus 1/6 all over 12. That is multiplied by 3, multiplied by the 2. So that is a 1, and divide that 2. That's 1/2. Right? Okay, much better. Wow, that was worrying. And 1/2, of course, is 0.5. So go a bit. This is 1. This is 0.5. 0.6 is about right there. And 0.5 is right there, so it's about right there. That's the center of mass. And I have another problem. Sometimes the density is constant. It's the same everywhere, which means it's the same material, same thickness. Find the center of mass of a thin plate of constant density. And here, if the density is constant, then you could use symmetry easily. Parabola 25, let's say this is 25. figure out where that is, I need to kind of scale this. Let's say that's 5, 10, 15, 20, 25. And that's radical 5, and that's 5 and minus 5. So the region bounded by the parabola and the x-axis, okay? So they're talking about this region. And in case you have a hard time seeing these colors, it's really right there. Well, since the density, first I start with m. M is the integral from negative 5 to 5 of delta times 25 minus x squared dx. M would be delta times 25x minus x cubed over 3 evaluated from negative 5 to 5. I could have used symmetry on this and just went double from 0 to 5 since the density is constant. So 25 times 5, that is 125 minus 125 over 3 minus and negative 125 minus 125 over 3, a plus when you put the negative in. So m turns out to be density times 125 plus minus 125 over 3 minus plus 125 minus 125 over 3. I'm getting m to equal delta into 250 minus 250 over 3, and that turns out to be delta over 3 times, if I multiply this by 3 top and bottom, that's 750, that's 500 over 3. There it is. Now, I know x bar is 0 because the density is 0, so symmetry, it's going to be along the y-axis. Y bar is going to equal, in this case, the integral from negative 5 to 5 of delta times 1/2 times 25 minus x squared squared. Remember here, that is the actual function. So I didn't take top minus bottom, the bottom is 0, dx of course, and that's going to be delta over 2 times the integral from negative 5 to 5, and wouldn't that be 625 minus 50 x squared plus x to the 4th dx? This is delta over 2 times 625 x minus 50 x cubed over 3 plus x to the 5 over 5 evaluated from negative 5 to 5. That's going to equal delta over 2. Actually, I should have did that from the beginning. That's okay. That is 1 over m, right? So 625 times 5, oh boy. 625 is 5 to the 4th. So this is 5 to the 5th minus 50 over 3 times 5 cubed plus 5 to the 5th over 5 minus a negative 5 in there. That is 5 to the 5th negative plus 50 times 5 cubed over 3 minus 5 to the 5th power over 5. So that would be, now if I put this in, isn't that going to be 3 over delta times 500 times delta over 2, and delta will cancel out every time, times, and let's see what this is. This is going to be plus, so you have 2 of those, This is going to be minus. You have 2 of those. And this is going to be a plus. You also have 2 of those. That's 5 to the 4th. Right? And 3 over 1,000, or 2 times 500, since there are a lot of 5s, right? Times, let's see, I could take a 5 to the 3rd out of all of those, and a 2 out of all of those. I could factor a 2 times 5 to the 3rd. I will have 5 squared, which is 25. I will have a minus 50 over 3, right? And a plus 5. There, nicest way to do this. Those 2's cancel out. This is 5 squared now. This is 100. I could reduce it more. But here, what do I have? I have 30 minus 50 over 3. I could divide by 25, which is 5 squared. That will make that a 4. That is 3 over 4 times over 3. 3 times 30. 90 minus 50 is 40. The 3's cancel out. Oh, what do you know? Oh boy, I must have messed up somewhere. Let me double check. Actually, I didn't mess up. I don't make mistakes. That's a joke. So, x bar, y bar is actually 0, 10. I thought I was looking at the 5, but this is y bar. So, if you go 0, 5, 10, that is the center of mass right there. And there's the homework.